Okay, let us see these two examples. We start with this one. Okay, a particle of mass 15 kilograms. I've already done this case because we have seen many examples and network about these ones, inclined planes. So, a particle of mass 15 kilograms is pulled up a smooth hill, so you don't expect anything like friction because it's a smooth hill. By a lightning extensible string parallel to the slope. It's not a string and it's pulling it is parallel to the slope, which is inclined, which is 10.5 meters and long. So this from here up to here is 10.5 meters long. Inclined at, so this is the inclination. That's what it means. So it means that the angle of inclination is equal to sine inverse of 4 over 7. I told you whenever you have this, don't compute this angle. All you do, take this side and you get sine as a trig ratio, as you see there, to the horizontal. If the acceleration of the particle is the acceleration of the particle, because it's being pulled up, it means that it's going to go up the hill, so the acceleration is going to be in that direction. If the acceleration of the particle is 0.98 meters per second, find the tension in the string. So starting with the tension in the string, in our part A, the tension in the string is the force that is going to be pulling it up the hill, as you see from there. So resolving, because this is a 15 kilogram mass, it's going to be having a weight of 15 D. Then to resolve this, we are going to be having always this one as 15 D cos theta. Then this one is going to be 15 D sine theta. So we are pulling it up, but the sphere is going to receive this resistance here. So from there, if we act the direction of the acceleration, because it's the tension we want, so the direction of acceleration in that order, A, so that always our resultant force is equal to MA. From Newton's second law, it says that the resultant force is always in the direction of the acceleration. So the resultant force is what we are going to see, those which are pulling it up in this direction minus those which are opposing in the opposite direction. So what is pulling it is T. Then there is a force which is opposing, this one which is opposing, which is 15V sine theta, equal to the mass of the particle, 15, then times the acceleration. Our acceleration from here is 0.98. That's our acceleration, 0.98. So now, from here, we have this. From here, I think you see using the angle they gave us this. So I could easily get my sine theta as this. So I want this, when I take the other side, I'll be having 90 equal to 15 into 0.98, then plus 15. Now this D is 9.8, then sine theta which is 4 over 7. And from there, the answer is going to be in newtons, because we are dealing with the tension in a string. So that's going to be so here I'm getting 98.7 newtons. So that's going to be the tension in a string with the AC. So from there, then work done against gravity. Know that always our work done against gravity is equal to our work done against gravity is equal to the change in in our part B. There is some. Okay, our work done against gravity. Our work done. Sorry. So our work done against gravity. Said our work done against gravity is always given by mdh. In simple terms, we need this height. This work done is always against gravity, so we need the height at which that particle is going to be from the ground. So if we consider this, now I'm going to be having such a case here. Okay, let me sketch it here. So you know we have from here up to it's 10.5 meters. So we need this height. Because what then I'm going to swipe there when the particle reaches the end of the slope. It means that now it's going to complete the whole distance at the slope, because that's that the slope is 10.5 meters long. So when it reaches the end of the slope, so it's going to cover this. So now we need this height from the horizontal, from the ground up to here. That's the height we are looking for. If this is theta, then this one is opposite or by hypotenuse. You have this, you need this, and this one from there. You can appreciate that our sine theta is going to be the opposite over the hypotenuse. So from there, our h is 10.5 sine theta, but we have sine theta from here as 4 over 7, and from there, my height is going to be going to be 6 meters, so that's going to be my height. So my work that I'm going to subtract to say it's going to be the mass of the particle, which was 15, times gravity force, then times our height, which is that. And sorry, press that. The answer I get is 882 joules, and that will be our answer. So whenever they ask work against the gravity, you always get the height from the horizontal. Of course, they'll give you that distance in most cases. Okay, if they asked work, if this was a rough frame, they would have asked also for work against friction, where it is given by mu r times the distance. Now the distance there is one which you have moved in opposition of that friction. Anyway, that's another day. So here we have another, a car of mass 1600 kilograms slides down the hill. Nice that it's sliding down the hill. So this is the direction of the acceleration. The direction of acceleration is very important. When a car descends 200 meters, so when they descend, so from there, 200 meters, along the hill, its speed increased from 3 meters to 10 meters because it was sloping, that's why the speed was increasing. Actually, the change in kinetic energy. So, to put, this is our car, we are showing that is our, I don't know here a car. You show that this is a car because the car is also a particle. Because it's when we get the mass times gravity to get this weight acting on that car. Of course, it's going to be having some resultant. I mean, a reaction between this and then slope. Then we resolve this. This will be cos, and then this will be sine. I think we saw that in the video, the first 2 videos on resolving this. Okay, so we start with this one, which they are saying descends a hill 1 in 25. So whenever I hear 1 in 25, it means they are giving you the size of that slope. It means that for every 1 unit increase in the height, the slope is increasing 25 units. So that's as simple as that. So this is always our theta. Then this one will be sine theta equaling to the opposite over hypotenuse. As simple as that. Now, from here now, we want to get a change in kinetic energy. So my part A, change in KE is given by half m v squared minus v squared. Because you see from here, our final resistance B, that's why you start with B now. So we have our mass, sorry. Okay, sorry, that means now we come and get our change in kinetic energy. So this is a half. So we shall be having here a half into now our mass, the mass of this which was 160 into now the final. So from there you can see that our final, our V was 10, then our U was 3. So 10 squared minus 3 squared, and from there you directly replace your answer. That's going to be this would be 72800 joules. And then they're asking for the average value of resistance. The average value of resistance, this one here. But remember, our curve is going downwards. So from there, you can use the either that work is equal to the change in E. As simple as that. So this is our change in kinetic energy. What is our remember is given by the force that is pulling the body, then times the distance. But our change in kinetic energy here is 7,800. So do we have the force? Now this is the resultant force that is pulling it up. We are going to be having this force, then minus the opposing force, then times our distance. From there, so our distance was 200 meters. So our S was 200 meters. So from there, now my force that is pulling in this acceleration rate, or is based on the direction of the acceleration is C. So the resultant force is what we are looking for. So the resultant force on this is going to be 160 sine theta. Then minus there is this force, the resistance force opposing. Then times the distance which we are covering in that resistance, 200 equaling to 72800. From here, if we see, we can divide from back, this would be 9.8. Our sine theta now is going to be 1/25 minus r equal to, if we divide this side, we shall be having 364. And so now, see that from there, you can get your R, your resistance, straight away. So how are we calculating it? We are getting this times this divided by this, and we bring this side and we take this side. So it's going to be now 169.8 over 25. So here I'm getting the answer as the answer is 263.2 newtons. That's going to be the resistance first by the average value of resistance in motion. This force is going to be causing that. Maybe it can be because of the friction, it can be because of the air resistance, and so on. So that's it, members. I wish you well.